Hey everyone, I wanted to make a video that walked through the process of dimensional analysis and some basic examples with you so that you could follow up from our assignment today, or those of you that weren't with us have access to the lesson. So, my two definitions go along with your notes from the guided reading from section 1.3. And hopefully, these terms start to make a little more sense now that you've had some exposure to them and some practice already. So the first one is dimensional analysis, which is a problem solving process used when we're converting between units, whether it's English system, SI system, or the combination of the two. It allows us to lay out the process of canceling units and getting to our final solution in a pretty simplistic way. Dimensional analysis uses conversion factors, which are ratios or fractions that are unit equivalents. So, whether again we're working English system, SI system, whatever it is, those units will be equal to each other. And so that ratio or fraction will always equal 1 in the end. So, I'm going to go through and do a practice one with you and then actually do a practice 3 with you. So our first problem that we're going to do here is, let's say I ask you to convert 48 inches to feet, right? A lot of us can do this in our head, but we want to be able to use dimensional analysis. When you're doing these problems, you do have to show your work and you do have to show canceling units. Otherwise, I'm just going to be assuming that you went to the internet and you just typed in this exact question and got an answer from it. So you got to be able to show me how you got to that process. Again, it's taking what's going on in your brain. If you can immediately solve this problem, and then figuring out a way to show that work on paper. So I'm going to kind of pose some questions, and you can always pause the video as we're going along here. But I want to make sure we are on the same page and you kind of have like a tiny Miss Peterson on your shoulder as you're working through these, because I'm going to repeat myself in each step of how you would complete these dimensional analysis problems over and over again. So our first thing that I want to talk about is conversion factors. And as we're looking at this problem, converting 48 inches to feet, right? I'm just highlighting those pieces for us. Our first conversion factor is going to be finding the equivalence between inches and feet, right? And so we should know already, or it should be kind of ringing in our head, that, hey, there's 12 inches for every foot. So I know that's my conversion equivalent. And when I turn it into a conversion factor, I can end up with two different potential fractions. I could put 12 inches on top and 1 foot on the bottom. And then I could do the opposite, 1 foot over 12 inches. Those are two different conversion factors. And we can see that they're just kind of like inverses of each other. And it depends on, how I'm solving my problem. I might want one or the other when I'm doing my conversions. So let's set up the problem I'm just going to kind of separate that out. And that's my conversion factor stuff. And let's solve our work over here. So my first step, which I'm going to highlight over here, is I'm always going to say, what do I put in the top left corner box? Okay. And in your head, hopefully that reminds you, we're always going to start with our given measurement. And so that's our value and unit that we know from the problem. So I'm going to start with 48 and I'm including my unit inches in there. If I don't put my unit, I am way more likely to make mistakes. So the unit is going to allow me to remember what units I'm canceling. Okay, so what goes in the top left corner? The given measurement, what I know from the problem. So 48 inches goes in there. What do I put below it? I'm going to put a 1 so that I have a fraction form. My next question I'm going to ask, what is the unit that I'm going to put in the denominator or the bottom right corner? The answer to that is the same unit that I started with from my given measurement. So that's going to go in the opposite corner. Why does it go there? That way I can cancel it out. What unit is going to go in the numerator or the top right corner? And that's going to be my final unit that I'm trying to solve for in the problem. So I'm going to put feet up top. Okay. And from there, now I need to decide which conversion factor am I going to use in order to properly fill out the rest of my dimensional analysis unit conversion piece, right? So I know I have feet on top and I have inches on the bottom. So I'm going to find the one that corresponds with that, right? And am I highlighting that as I go along here? So I'm going to put 1 foot, oops, got to get my marker, 1 foot over 12 inches. Right? So those of you that simply did this problem in your head and you said, oh, Miss Peterson, this is clearly 4 feet per 48 inches. You should be able to show me using dimensional analysis like this, what's going on inside your head. And just to finalize things, these inches should cancel out with those inches. And then when I'm actually solving for this, right, 48 divided by 12, because the number in the denominator, I'm going to divide anything that's down and I'm going to multiply anything that's across. So 48 divided by 12 is 4. And my final answer is feet, or final unit is feet. So that's my first problem for something that's pretty simplistic. Okay? But I want to be able to kind of follow along those steps. And I'm going to drag this piece. Oh, no. What's this part? That's very odd. Okay. Get out of there. I'm going to drag this down here below for our next problem. Okay. Our next problem that I'm going to do is going to involve, maybe a couple of different steps. So this time I'm going to say, how many cups in 80 gallons? Again, I want to be able to use dimensional analysis and use my conversion factors. And I'm going to just kind of think about the process for this. And I'm just going to make this a little bit bigger. Sorry, that's kind of messing around with things. But I want to talk about, the problem solving process in my head. So in this area is my volume location, right? I can see I'm working with gallons and I can get to quarts. But my goal is to get to cups, and I have this other conversion of quarts to cups as well. So in my head, when I do my conversion factors, I'm going to have to take a few steps to get here. Sorry. I'm going to start with my gallons. I'm going to go to quarts, and then I'm going to go to cups. And I'll be able to get my final answer. Okay? So for this one, I'm going to have 2 steps of solving my problem instead of just one that I had earlier on. Okay? So my first question is, what am I going to put in the top left window? Top left window is my starting measurement, right? So my given value. So I'm going to start with 80 gallons. What do I put underneath it? I put a 1 so that it's in fraction form. What unit goes in the bottom, in the denominator of my next window? The same one as before. So I'm going to put gallons down here. My next step, what unit goes above it? The new one I'm trying to solve for, which is in fact quarts this time. So I'm going to simplify that and write quarts. I'm going to go over and continue this trend for my next step before I even fill in my conversion factors. What unit am I going to put in the denominator of my next window? Well, I'm going to try and cancel out quarts next. So that same one I had above, it's going to go below, right? Same goes in the opposite corner. And then my new one is going to go in the numerator, and that's going to be my final one, which is cups, right? If I go over here again, here's my conversion between gallons and quarts. 1 gallon equals 4 quarts. So when I go to write out my conversion factor, I can have 1 gallon over 4 quarts, or do I want 4 quarts for 1 gallon? Based off of the layout, I want quarts on top, so I'm going to put 4, and I want gallons on the bottom, and I'm going to put 1 with that. And I'm going to do the same thing for quarts and cups. 1 quart equals 4 cups. So I'm going to put the 1 quart next to there, and I'm going to put my 4 cups next there. Okay. When I solve for this thing, every number is on the top. And I want to make sure, again, confirm before I move on, that I properly set this up. So I'm crossing out gallons, I'm crossing out my quarts, and I'm going to end up with cups, just like my problem was asking in the beginning. So I know that I've set this up correctly. Okay. When I solve this, like I was saying, all my values are on the top. So I'm going to multiply across 80 times 4 times 4. Okay. And then when I get my final answer, somebody else can, call me out if I did this incorrectly, but that should be 1,280 cups. And that's my final answer. Okay, so hopefully those couple examples help you out where we have our values on the top, the bottom, where we could have multi-step versus single step. And let me know if you have any specific questions as you're working through these, okay? Otherwise, I will see you all tomorrow with your questions.